Next, let us see that consumers market point of view adoption. Here, when we developing IoT solutions and products for getting the consumers market, vendors know that consumers access to applications and devices will occur predominantly over broadband and mobile wireless infrastructures, and the main customer devices range from smartphones to tablets and PCs. The common protocol that links IoT in the consumer space to these devices is IP. Without IP, these things are zero. Means to say that we are not able to connect anything, even though we are going to have a number of mobile phones, tablets, notebooks, PCs. Without IP, nothing it is. We are not able to connect to the Internet of Things, the outside world. So we should know that which are the protocols, which of the applications that consumer wants. Based on that, the applications are being built in the Internet. At the end, let us move to the last one, that is the innovation factor. Very, very, very important thing. So here, in the past 2 years, predominantly the innovation factor is coming into the picture of everywhere, as Prime Minister Modi has given one of the solution that whatever the innovations are going to be done in the college, so that it is going to be getting recognized. So everywhere, every institutions are now coming up with the innovation factor. The best part of this is innovations in IoT can also leverages an IP understanding. With the IP, IoT is going to be more powerful. And even the recent computing evolution from PC to mobile and mainframes to cloud services are perfect demonstrations of the innovative ground enabled by IP. So nowadays, whatever we think, the data, about the data, that can be kept in a cloud services where wherever we go, that it is going to follow. So it is like that. So we don't need any data to be carried from our pen drives. So if the internet is there, IP, internet is there, we can access anywhere that particular data. So these are the main advantages of the IP for the Internet of Things. Next, let us see that the business case for an IP adoption or adaptation of the Internet protocol. What do you mean by adaptation? Here, the application layered gateways, ALGs, must be implemented to ensure the translation between non-IP and IP layers. Non-IP layers are the physical layers, IP is getting connected in the network layers. And there are so many protocols we have to adapt, and adaptation through the gateways that we can connect. Adaptation involves replacing all non-IP layers with their IP layer counterparts, simplifying the deployment model and operations. So here it deals with network layer protocols in adaptation to IP. One point of constraint between computer networking experts. Here in the adaptation model, the implementation to ensure that translation between non-IP and IP layers. In case of adoption, we have non-IP layers with the IP layer counterparts, simplifying the deployment model and operations. How this is getting adopted? Let us see the factors when trying to determine which model is best suited for IP connectivity. There are four models. One is bidirectional versus unidirectional data flow, overhead for last mile communication paths, data flow model, and network diversity. What happens in case of bidirectional versus unidirectional data flow? Here, while bidirectional communications are generally expected, some last mile technologies offer optimization for unidirectional communications. Example for that is RFC 7228 may only infrequently need to repeat a few bytes of data to an application. And the LPWA, where the low power wireless technology that is going to be used, and which includes the applications like fire alarms, sending or delay test reports, then electrical switches being pushed on or off, and water or gas meters reading weekly indexes. These are the applications, bidirectional, unidirectional, that it is going to be posed. For these cases, it is not necessary worth implementing the full IP stack. So some of the applications needs bidirectional and some unidirectional. Second is overhead for last mile communication paths. Here, the IP adoption mile implements the layered architecture with the peer packet overhead that varies depending on the IP versions. So as we know that there are two versions are there. There are four versions rather. IPv4 is going to have 20 bytes, IPv6 is going to have 40 bytes, UDP has 8 bytes and TCP has 20 bytes. So it depends upon the applications, the protocols are going to be used. The data is to be forwarded by the device is infrequent and only a few bytes, we can potentially have more header